Question 1a, work out 3 times 19. So I'm going to partition this. I'm going to split 19 into 10 and 9. And I'm going to work out 3 times both of those values. So 10 times 3 is 30, 9 times 3 is 27. And then I'm going to add those together to get my final answer. 0 plus 7 is 7, 3 plus 2 is 5. So 57 is my answer. Part B, work out 3.162 plus 10.57. So we're adding decimals here, so we need to be really careful. We're going to write out the column method, but we're going to make sure that our place value and our decimal points line up. So we have 3.162 and we are adding 10.57. The decimal point has got to line up. This 3 is in the ones or the units column, which is where that 0 needs to be. So that's how I'm going to write 10 and then the 57 underneath. Now we don't have to put anything here, but you can put a placeholder 0 to complete that column if you want to. And then we're just going to add as normal. 2 plus 0 is 2. 6 plus 7 is 13. So I'm going to write the units, carry the 10. 1 plus 1 is 2. Plus 5 is 7. My decimal point is going to match the decimal points above it. 3 plus 0 is 3. 1 plus, there's a 0 there, technically, is 1. And 13.732 is our answer. Part C, again, we are working out. So we are calculating 8 add 6 divided by 2. But we need to remember order of operations, guys. We have to do the division before we can do the addition. So 6 divided by 2 is 3. So we are actually doing 8 plus 3, which is 11. Part D, write 18 over 24 in its simplest form. So we're looking for a factor of 18 and a factor of 24, a number that we can divide both the numerator and the denominator by, that has to be the same. So 18 and 24 are both even numbers. So I'm going to start by dividing them by 2. Doesn't matter if we do this in multiple steps. So 18 divided by 2 is 9. 24 divided by 2 is 12. Remember, when you're dividing by 2, you're halving. Now I'm going to check if this is in its simplest form or not. So 9 and 12 are both in the 3 times table. So I can divide the numerator and denominator by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. Check if it's in its simplest form again, guys. 3 and 4, the only common times tables they appear in are the 1 times tables. So that's our final answer in its simplest form. Part E, write 0.32 as a percentage. So currently it's a decimal. We want to write it as a percentage. So to write a percentage as a decimal, we a decimal as a percentage, we multiply it by 100. So we're going to do 0.32 multiplied by 100. When we're multiplying by 100, okay, all of these digits are going to shift to the left 2 places. So 0.32 becomes 32. And then the next one, write down a value that is less than -10. So think about how a number line works here, guys, okay? That's what's important. So we have a number line. And let's put -10 there. Numbers going this way on the number line are getting closer to 0. So that would be -9, -8, -7, -6, -5, and it would go all the way up to 0. Okay, those numbers are greater than -10. We want less than -10, so we want a number on this side. The next number on the number line would be -11, so that's the number that I'm going to go with. It's a value less than -10. Question 2. The bar chart shows the percentage of households in the UK who owned at least one mobile phone in the years 2000 and 2009. So you've got percentage of households, and then the bars tell us our frequency. So this is the bar for 2000, this is the bar for 2009. What was the increase in percentage of households who owned at least one mobile phone from 2000 to 2009. So we need to know how many households in each year to start off with. So we're going to find the total of these bars. So in 2000, if we read across here, in 2000, we've gone 10, 20, 30, 40. Now we need to figure out what this scale is here. So we've got to be really careful. So between 40 and 50 are 10. Okay, 10 households. But we've got 1, 2, 3, 4, 5 lines. 10 divided by 5 is 2. So each of those lines is worth 2. So we've got 40, 42, 44. So we've got a total of 44 households in 2000. Let's do the same with 2009. So we want to read across, and I'm drawing a line across because it will help me read the scale here, guys. So in 2009 we were at 80, and then we're halfway between these lines. Well, each line is equal to 2, so halfway between must be 1. So that is 81. So in 2009 there were 81 households. So we want the difference between them. We want that increase in the percentage of households. So how many more in 2009 compared to 2000? So we're going to subtract those two values. 1 subtract 4, we can't do that and get a positive value. So we're going to borrow here to make that 11. 11 subtract 4 is 7. 7 subtract 4 is 3. So the percentage increase is 37%. Part B. In 2018, 95% of households in the UK owned at least one mobile phone. Complete the bar chart. Okay, so 2000 is 44%. Remember, it's the percentage. 2009 is 81%. 2018, this next bar is 95%. So I'm going to draw this in pen because I want you guys to be able to see it nice and clearly. But remember, in your exam, you will use a pencil. So you can rub it out if you make a mistake. So we're looking at where 95 would be for our 2018 bar. Well, 90 is here. We said each one of these lines is 2. So that's 90, 92, 94. So 95 is going to be halfway. Okay, so we're getting halfway between those two lines. So I'm going to draw our 2018 bar. So that is 95% of households for part B. Part C. Comment on how mobile phone ownership seems to have changed between 2000 and 2018. Okay, so let's have a look. In 2000 it was 44%. In 2009 it's gone up to 81%. And then in 2018, it's gone up again to 95%. So the comment that we can make here about how it's changed between those years is that the percentage of people owning mobile phones seems to have been increasing, or more people or households seem to be owning mobile phones. So let's go with the percentage of people owning mobile phones seems to be increasing because it's gone up every year. Question 3. Sally has 2 sets of cards. So 3 cards have letters on them and 4 cards have numbers on them. So that's our 3 letter cards and our 4 number cards. She shuffles each set and chooses 1 card from each set at random. Complete the table to show all possible pairs of cards. Now what it says here is really important. It says we may not need all the lines in the table. Okay, so be aware of that. They've given us lots of lines, but we might not need to use them all. So don't let that throw you. And they filled in some possible pairs for us already. So they've started with, if they picked a letter A, they could also then pick a number 1. If they picked the letter A, they could also pick the number 2. So we can add that if they picked a letter A, they could also pick the number 3. And they could still pick the letter A, but then also pick the number 4. So at this point, we've dealt with the letter A being picked with each of those numbers. So we're going to do the same with letter B. So if B is picked, they could pick 1, they could pick B and 2, B and 3, B and 4. So we've dealt with the letter B, and we're going to do the same for C now. So they could pick card C with the number 1, C with the number 2, with the number 3, and with the number 4. And you'll see we've got some spaces left, but that's okay. We've dealt with all 3 letters occurring with all 4 numbers each time. Question 4A. So we've got a diagram here with some angles labelled. It's not drawn to scale, so we can't use a protractor and measure anything from it at this point, guys. They want us to find the value of W, so we want to know what that angle there is equal to. So the first thing we need to recognise, okay, is that we are dealing with these intersecting lines. So we're dealing with vertically opposite angles here. So this angle 80 is equal to this total angle opposite on the other side. Now we know what part of that total angle is, it's 65. So that W must be what's left to make 80, because they're vertically opposite, so these two have got to be the same. So if we do 80 subtract 65, that will tell us what W should be. Now we can't do 0 take 5 and get a positive answer, so we're going to borrow from our tens column. 10 take away 5 is 5, 7 take away 6 is 1, so W is equal to 15 degrees. Part B. So here again, we've got another diagram not drawn to scale, so we can't measure anything directly from it. The diagram shows an isosceles triangle, and we know it's an isosceles triangle thanks to it telling us that those two sides are equal by using the dash that you can see there. It wants us to find the value of X and the value of Y, so these two angles here. So it's an isosceles triangle. These two sides are the same. So because those two sides are the same, that tells us that the base angles at the bottom of those sides must also be the same. So this angle and this angle must be equal. So straight away we can say that X is 70 degrees because it's an isosceles triangle and the base angles at the bottom of those equal sides are the same. Now we're going to find Y. Well, angles inside a triangle must add to 180. So we're going to take 70 plus 70, which is 140, and we're going to take that 140 away from 180 to tell us what Y is. So 180 take away 140 is 40 degrees. So we're going to pop there, Y is 40 degrees. Question 5. Matt has 120 music albums. 3/5 of his albums are CDs, 15% of his albums are vinyl records, the rest of his albums are digital downloads. How many of Matt's albums are digital downloads? So we need to find out how many are CDs, how many are vinyl records, and then subtract that from the total to figure out what the rest of them are, or how many the rest is, I should say, and then that's our digital download. So we're going to start by finding 3/5 of 120, so 3/5 of 120. So to find a fraction of amount, we're going to divide by the denominator, multiply by the numerator. So divide by the bottom, multiply by the top. So we're going to start by doing 120 divided by 5. So let's do our 5 times tables to help us out. 5, 10, 15, 20, 25, 30. We'll just stop there for now. So we're going to do 5s into 12. So 5, 10. So we're going to stop there, otherwise we go past 12. So that's 1, 2 whole 5s. And then the remainder to get from 10 to 12 is 2. So I'm going to pop a 2 there. So now I'm doing 5s into 20. 1, 2, 3, 4 gets us to exactly 20. There's no remainder. So 120 divided by 5 is 24. But we now need to multiply by 3. So 24 multiplied by 3. I'm going to partition this. I'm going to do 20 multiplied by 3 and 4 multiplied by 3 to split it a little. 20 multiplied by 3 is 60. 4 multiplied by 3 is 12. And when I add them together, I get 72. So there are 72 CDs. We're going to need to use that shortly. Okay, 15% of his albums are vinyl records. Okay, so we need to find 15% of the original, guys. So 15% of 120. So 15% of 120. Well, let's split it. Let's find 10% and 5% because 10% plus 5% will give us our 15%. And we can treat it a bit like column addition if we do it this way. Okay, to find 10% then, we divide our amount by 10 because 10 times 10 is 100. So 120 divided by 10 is 12. To find 5%, we find 10% and then half it because 5 is half of 10. Well, 10% is 12 and to half it we divide by 2, so that's 6. 12 plus 6 is 18, so our 15% is 18. So there are 18 vinyl records. We're also going to use that amount again. Okay, so 72 CDs, 18 vinyl records. The rest of them are digital downloads. So CDs plus vinyl records is 90 in total. Okay, so CDs plus vinyls is 90 in total. So we're going to do 120 take away 90. 0 take away 0. 2 take away 9 we can't do and get a positive answer. So we're going to borrow from here to make that 12. 12 take away 9 is 3. So there are 30, because this is the rest, 30 digital downloads. Question 6. Small oranges cost X pence each. Large oranges cost twice as much as small oranges. Write an expression in terms of X for the total cost of 4 small oranges and 6 large oranges. Give your answer in its simplest form. Okay, so small ones cost X. That's handy. Large ones cost twice as much as small ones. So small ones cost X, large ones must cost 2X. Okay, so now we want an expression in terms of X for the total cost of 4 small oranges, so 4 lots of X, so 4 times X, and, so plus 6 large oranges. So we want to do 6 times 2X, because each large orange is worth 2X. Now notice I put brackets there because we're doing 6 multiplied by 2X. Okay, guys? So we have 4X, and then 6 multiplied by 2X is 12X. And we want it in our simplest form. So we've got 4X, add 12X. These are like terms. They've both got exactly the same letter and exactly the same power. So we can add them together. We have 4 of them and 12 of them. So we have 16 of them in total. Okay, part B. Lemons cost Y pounds for a bag of 4. Write an expression in terms of Y. So we're working with Y this time for the cost in pence of 1 lemon. Okay, so they want the cost in pence, but they've given us Y in pounds. Okay, so what we need to realise is £1 is 100 pence. So instead of Y, I'm going to use 100Y. Okay, it'll be easier to use, so bear with me on that. And then that is for a bag of 4. Okay, well, we don't want a bag of 4, we want 1. Okay, we want the price of 1 lemon. So we're going to divide by 4. So we want to get to 1. So 4 divided by 4 is 1. So 100Y divided by 4 must give us the price of 1 lemon. 100 divided by 4 is 25. So 25Y is an expression for the cost of 1 lemon. Now I know I've written equal signs here, guys, but it's purely to lead into the simplifying aspect. All right, so this is our final simplified expression. It's not an equation. Question 7. Thomas owns a takeaway food shop. Here's part of the menu. So this is part A. So 1 chicken piece. So 1 costs £2. 2 costs £3.20 and 3 costs £4.20. So Jean orders 4 chicken pieces and Thomas charges them £6.40. For this first part, they want us to show how Thomas has worked out the cost of Jean's 4 chicken pieces. So we've got to compare the costs here with the price that Jean's paid so we can figure out how Thomas has worked this out. Okay, so there's 4 chicken pieces. So if he'd have charged £2 per chicken piece, that would have been 4 times 2, which would have been £8. He hasn't charged £8, so he's not used it as single chicken prices. We're going to look at the 3 chicken pieces. That's £4.20. So the difference between £4.20 and £6.40 is £2.20. Nothing costs £2.20. So he must have gone with the 2 chicken pieces price, which makes sense because 2 is a factor of 4. 4 is a multiple of 2. So what he's done is he's worked out 2 times £3.20 to get the £6.40 for Jean's cost. Okay? Jean says, you've charged me 20 pence too much. Show how Jean might be correct. Well, the other option we've got here is that there's another way of making 4. So 4 pieces, we did 2 times 2, but what if we did 3 plus 1? Okay, so 3 chicken pieces is £4.20, 1 chicken piece is £2, and when we add those together, that gets £6.20, which is 20p less, isn't it? It's 20p less than what she's being charged, so that's how Jean may be correct. Okay, part B. Thomas orders some food trays. The table shows his options. So he can buy these different number of trays. So for 25 trays, it's £5. For 50 trays, it's £9. 100 trays, it's £17, and so on. He spends exactly £83 on trays, and he orders as many as he possibly can. So we have to figure out how many trays he orders. So he spent £83 on trays. So he can't have ordered 1,000 because he hasn't spent £99. Okay. So he's definitely not ordered 1,000, but he could have used a combination of any of the others. Okay, so we're going to figure it out here. So I'm going to start by combining values to make 83 trays. Now, if he wants to order as many trays as possible, I'm going to see how many of the larger number of trays we can get first. So he can get 250 trays for £33. Okay, so let's do 83 take away 33. So that leaves him with £50. So he could do that again. He's got enough left to get 250 trays again. So if we do the £50 take away the 33, remember 0 take away 3 we can't do and get a positive answer. So we're going to borrow. 10 take away 3 is 7. 4 take away 3 is 1. So he's got £17 left. Remember, this is the money that he's spent, £17. So he's done 250 trays, 250 trays. So he can get 100 trays as well. So 100 trays would cost the whole of that £17 that he's got left. Okay. So we want to know how many trays he ordered. So we're interested in this total now. 0 plus 0 plus 0. 5 plus 5 is 10, plus 0 remains at 10. Carry the 1. 2 plus 2 is 4, 5, 6. So he orders 600 trays in total. Question 8a. Find 2 whole numbers that have a difference of 20 and when one is divided by the other, the answer is -9. So we're looking for 2 whole numbers, a difference of 20. One, when divided by the other, gives us an answer of -9. So the important thing here is if we get an answer of -9 when we divide, that means that we must have a positive number and a negative number, because that's the only way we're going to get a negative answer when we divide. So we're looking for a positive and a negative number. So I'm going to start by thinking about numbers that would divide to give me 9. So we're going to work with our 9 times tables here. So 1 times 9 is equal to 9. So that tells me that 9 divided by 1 is equal to 9. 2 times 9 is equal to 18. So that tells me that 18 divided by 2 is equal to 9. 3 times 9 is 27. So that tells me that 27 divided by 3 is equal to 9. So let's just start with these ones for now. We're aiming for -9, but I'm working with my 9 times tables. And remember that we need one positive and one negative number. So these are potentially our pairs that we're looking at the minute. But we need one of them to be negative to give us an answer of -9. So it could be that we do -9 divided by 1 to get -9, or we could do +9 divided by -1. Same here, we could do -18 divided by 2, or we could do +18 divided by -2. It's just one of them that needs to be negative. And then the same here, we could do -27 divided by +3, or we could do +27 divided by -3. All of those are going to get us that answer of -9. But we want the numbers to have a difference of 20. So let's have a look at this, and we're going to think about a number line, okay, guys? So when we work with a number line, if I draw one really quickly, it's going to be a rubbish number line, so just bear with me. So if we've got 0, 1, 2, 3, 4, and then we have the negative numbers like that, okay? So if we're looking at -9 and 1, well, -9 is going to be down here. And to get from -9 to 0 is 9 places, and then to get to +1 is another place, which is 10. So -9 and +1 have a difference of 10. We're looking for a difference of 20. So let's go with -18. So if we've got -18 here, to go from -18 to 0 is 18 places. But then we're going to +2, which is another 2 places. Well, 18 plus 2 is 20. So that's our difference of 20. So we're going to use these pairings. And it doesn't matter which pair I choose, whether I go for -18 and +2, or whether I go for +18 and -2. We're still going to get the right answer. So let's just write this first one down. Let's go -18 and +2. Okay, part B, find 3 whole numbers. So again, we're working with whole numbers that multiply to give 24 and add to give a total of -5. So that adding for a total of -5 is what's important here, because that tells us that we're going to need negative numbers as well as positive, because that's the only way we're going to get a difference of 5, of -5. If we add all positive numbers, we're not going to get -5 as an answer, are we? So we're going to need a mix of positive and negative numbers again, but we're looking for 3 of them this time. So I'm just going to start by finding numbers that multiply to give me 24, because that's the first criteria. So 24 is an even number, so I can do 2 times something. Well, it's 2 times 12 that gives me 24, but currently that's only 2 numbers. So what I'm going to do is I'm going to split 12 into 2 numbers as well. So I've got 2 times, and then I want 2 numbers that will multiply to give me 12. Okay, so I'm going to just go with 3 and 4. So 2 times 3 times 4. 2 times 12 is 24. 2 times 3 times 4 is also 24. Now we have 3 numbers. So let's get rid of these so we don't confuse ourselves. But the problem here is we've got 3 numbers, but we need a mixture of positive and negative so that when we add them, we get an answer of -5. So let's start by just making one of them negative and see what happens. Okay. So 2 times 3 times -4. We've got a positive times a positive, which gives us a positive, times a negative, which gives us a negative, and we want a positive answer, so it's got to be 2 of them that are negative. Okay, so let's do 2 times -3 times -4. Well, 2 times -3 is -6, times -4 becomes +24. Okay, so this works, but we need to add for a total of -5. So if we're adding them, we have 2 plus -3 plus -4. Remember, those signs stay with those numbers. So 2 plus -3 becomes 2 minus 3, and then plus minus here becomes a minus again. So 2 subtract 3 is -1, and then -1 subtract 4 is -5. So we're going to go with these 3 numbers here. So we're going to go with +2, -3, and -4. It's really important with these kind of questions that you're systematic, guys, and you just try things out. But remember those number properties. Okay, remember whether we're going to need positive or negative numbers. Question 9. Alan builds a model of a steam train. So first of all, if we're talking about models, I'm expecting to see a scale somewhere in this question, guys. Here we go. The scale he uses is 1 centimetre represents 75 centimetre. So this is 1 centimetre on the model represents 75 centimetres on the real train. So a real life full size train. Part A. The width of a wheel on Alan's model is 3 centimetres. What's the width of a wheel on the steam train? Okay, so we're working with this scale here, and I'm going to use a proportion table. We know that I like those if you've watched any of my previous videos. So we're dealing with the model and we're dealing with the actual train here, guys, okay? So on the model, 1 centimetre is the same as 75 centimetres on the real train. The width of the wheel on Alan's model is 3 centimetres. So I'm going to write that in my model column, 3 centimetres. And what we do when we're working with a proportion table is we scale up or we scale down. So we multiply or we divide. So to get from the 1 centimetre in my scale to 3 centimetres, I've scaled up, so I've multiplied by 3. So if I do the same on the other side of my proportion table, that will tell me what 3 centimetres is on the real steam train in actual real life train size. So we're going to do 75 times 3. So I'm going to do 70 times 3 and 5 times 3. So I've split 75 up into 70 and 5. Well, 7 times 3 is 21. So 70 times 3 must be 10 times bigger. So that's 210. 5 times 3 is 15. And when we add those together, we get 5, 2, 2. So it's 225 centimetres on the actual steam train. Now, there is no answer line on Eduqas papers, but you just need to make sure that your answer is nice and clear, or that they can see it if there's lots of working out. So let's just highlight that there for them. Part B. The length of a whistle on the steam train is 375 millimetres. So this is on the actual train, so the full size train, not the model. What is the length of the whistle on Alan's model train? Give your answer in centimetres. So the first thing we need to realise here is that we're given a length on the actual train in millimetres, but our scale is in centimetres and we want our answer in centimetres. So what will work really well here is if we convert millimetres into centimetres. So there are 10 millimetres in every centimetre, okay? So 10 millimetres is 1 centimetre. So to go from millimetres to centimetres, we need to divide by 10. So 375 millimetres divided by 10 is 37.5 centimetres. Remember, when we're dividing by powers of 10, the numbers shift in place value 1 place to the right for dividing by 10. So that's 37.5 centimetres. Now we can work with our scale again, our little proportion table. So we've got our model and we've got our train. So we've got 1 centimetre is 75 centimetres in real life. We've got that from our scale. Now we know that in real life, the length of the whistle on the actual train is 37.5 centimetres. So we're going to put that in the actual train column this time. So what you can see has happened here, we've scaled down because 37.5 is less than 75. So we've scaled down, so we must have divided. So we're going to have to divide this side. The tricky part is figuring out what we divided by. Now I know that 37.5 is half of 75. Okay, so I know I need to divide by 2 on both sides. However, if you didn't know that, you could do 37.5 plus 37.5 and add them together. So that's 5 plus 5, that's 10, carry the 1, 14, 15. And then you're like, oh, it adds to 75, so it's 2 of them. You could keep going until you see how many of them fit in. Okay, so that's just a top tip for you there. So we're dividing by 2. So we're going to divide by 2 to find out the length of the whistle on the model, and we're working in centimetres here, which is good. 1 divided by 2, I'm going to write as 1 divided by 2, which is a half. So it's half a centimetre, okay? So the length of the whistle on Alan's model train is 1/2 centimetre, and I'm going to make that nice and clear as my answer. Excuse me. Part C. Alan's model train has 6 wheels. Alan's friend Mandy says the steam train has 6 times 75, so that's 450 wheels. Explain why Mandy's not correct. So Mandy's not correct because this scale is in centimetres. It works with lengths only, guys, okay? Doesn't work with anything else. There's no way we'll have 450 wheels on a steam train in real life when the model only has 6 wheels. On the model when the train only has 6 wheels. Does that make sense? So we're going to say that, ignore my dogs in the background, I'm so sorry. The scale works for lengths only. The train will still have, sorry, my dogs are going mental, 6 wheels. So the number of wheels on that train, whether it's the real life train or the model, are not going to change because that scale only deals with modelling the lengths to give us a scale model of our train. Question 10. Nico's normal pay rate was £20 for each hour that he worked. Nico normally works 35 hours each week. Any extra hours that Nico worked were hours of overtime. And Nico's pay rate for each hour of overtime is 1.5 times his normal pay rate. Part A. Show that Nico earns £700 in a week when he does not work any hours overtime. So this is what we're looking for. If there's no hours of overtime, we're looking for what he normally earns before they pay him any extra. Okay? So his normal pay rate is £20 per hour and he usually works 35 hours a week. So we are doing 20 times 35. Now, how you do this is up to you. You can use the grid method or whatever. So I'm just going to partition this, okay? So I'm going to split 35 up as 30 and 5 and times both of those by 20. So 30 times 20. 3 times 2 is 6, but then we've got 10 times bigger and 10 times bigger. So that's 100 times bigger, so that must be 600. 5 times 2 is 10, but that's 10 times bigger. So 100, and then we're going to add those together. So 600 plus 100 is £700. So that is what Nico normally earns in a week. So we've shown that he earns £700. Part B, 1 week, Nico worked for 38 hours. Calculate his pay for this week. Okay, so in a normal week, he works 35 hours. Anything over that is overtime. So he does 35 normal hours. But then 38 take away 35. 8 take away 5 is 3. And then he's got 3 overtime hours. Okay, so the difference between what he normally works and what he did work tells us his overtime hours. That's an awful 5. I'm so sorry. So 35 normal hours and 3 overtime hours. Okay, so we're going to calculate his pay now. So his normal hours are £20. Okay, so 35 times 20. Well, we've done that up here, so we're not going to do that again. So for his normal hours, he's going to get £700. But for his overtime hours, he gets 1.5 times his normal pay rate. So for his overtime hours, he's going to get his £20 per hour plus half of that again. So half of £20 is £10. So for overtime, he gets paid £30 an hour. So we're going to do 3 times 30, which is 90. That's his overtime pay. So we're going to add that 90 to his normal pay of £700. So he earns £790 in that week. Okay, the next part. The next week, Nico earned £1,060. How many hours of overtime did Nico work? And we've got to show all our working. Okay, so we know from part A that in a normal week, he earns £700 for 35 hours. So let's get rid of that from here. Let's take away 700. Okay, so 0 take away 0. 0, 6 take away 0, 6, 0 take away 7, we can't do and get a positive answer, so we're going to have to borrow from here to make that 10, 10 take away 7 is 3, so he's got £360 of overtime pay, okay. Now, we worked out here that his overtime pay is £30 an hour. So we need to do 360 divided by 30. So I'm using the bus stop method here, guys. And I'm going to do some of my 30 times tables there to help me just in case I need them. So I'm going to do 30 into 36. Well, 30 goes into 36 one time. And to get from that 30 to 36 is a remainder of 6. So now I'm doing 30s into 60. So that's 1, 2. There's no remainder. So that tells me that he works 12 hours of overtime that week. Okay. Part C. The following week, Nico's normal pay rate increased. So his normal pay rate increased, he gets a pay rise. He did not work any hours of overtime and he earned £735 for that week. Show that Nico had a pay increase of less than 6%. Okay, so let's go back to the original question. Normally, before this pay increase, he earns £20 per hour. Okay, so the starting rate was £20 per hour. And that would earn him £700 in a week. Okay, so this time he's earned... Sorry, my dogs are going mad. Yeah, so that earns him £700 a week. This time he's earned £735 here. So we're going to see what the difference is between how much he's earned. So we're going to do 735 take away 700. So that tells us that he's earned £35 extra that week. Okay, so we're going to work out what 35 out of 700 is as a percentage. So we're going to write it as 35 over 700 because it's 35 out of 700. And then we're going to simplify. So we're going to look for a number that we can divide the numerator and denominator by. Now, they both end in a 5 and a 0. If anything ends in a 5 and a 0, it can be divided by 5 if it ends in a 5 or a 0. So let's divide by 5 to start off with. 35 divided by 5 is 7. Do the same to the bottom. 700 divided by 5. Well, there's 25s in every 100. And there's 700s. So 7 times 20 is 140. Okay. Now I know that 7 and 14 are both in the 7 times tables. And if 14 is in the 7 times tables, then 140 will be in the 7 times tables. So I'm going to divide by 7. There may be a quicker way to do this, but I'm just doing it the first thing that my brain spots. So 7 divided by 7 is 1. And 140 divided by 7 is 20. Okay? We want to know what it is as a percentage. A percentage is out of 100, so we're going to scale it up this time. Okay, guys? So to get from 20 to 100, we times by 5. So to get from 1 to the new numerator, we times by 5. So this here tells us that it's a 5% increase. Now, you might have said to yourself, well, what are you doing, Miss B? Because 35 and 700 are quite clearly in the 7 times tables. But what I've just done is shown you that actually your brain doesn't think like that sometimes straight away. So the first thing I spotted was 5, so I went with it. Had to do a few more steps, but it doesn't matter, all right? But we've shown that this pay increase is less than 6% because it's actually 5%. Okay, next part of, so part 2 of C. Dana works with Nico. They work the same number of hours. Dana had a pay increase of 6%. She says my pay went up by a greater percentage, so I earn more than Nico now. Explain why she may not be correct. Okay, so if they earn the same, so if they earn exactly the same hourly rate, okay, then her 6% increase is higher than his 5% increase. Okay, so she would earn more. But she could also have been earning less per hour than Nico. So you can either say if she was earning less per hour, then she might not be correct. Or you can say it would only be true if they're earning the same. I'm going to mention if she earns less. So Dana could be earning less than Nico before the percentage increase. Question 11. Ari has a biased spinner. The numbers on the spinner are 1, 2, 3, 4, 5, 6, 7, 8 and 9. The table shows the relative frequencies of some events using Ari's spinner. So the event is across here and then the relative frequency. So the relative frequency just shows us the chance, like how often that event happened. So on the spinner, Ari got a number less than 5 is a 0.75. Ari landed on 5 is 0.1 and a number more than 5, there's a blank for that. And it wants us to find, oh dear, the relative frequency of spinning a number more than 5. Okay, so the key we need to recognise here, guys, is probabilities have to add to 1. Remember that probability scale goes from 0 to 1. Impossible, certain, and all of the possibilities between that, okay? So they've got to add up to 1. So we're going to take these two things away from 1 to find the missing number. So I'm going to start by adding them together. Be careful here, guys. This is 0.75. This is 0.10. Make them look the same length. So put that 0 placeholder in so that you line things up in the correct place value columns when you're adding, or you're going to go wrong. So we're going to add these. That's 5. That's 8. So 0.85, so then we're going to take that away from 1. Again, 1 is 1.00 and we are taking away 0.85. Okay, 0 take away 5 we can't do and get a positive answer. We would borrow from here, but that's also 0. So we're going to have to borrow from here to start off with. So when we borrow from here, it becomes 0, but it makes the next column 10. That's what's important, guys. And then we borrow from this column to make it 9 to make this column 10. So 10 take away 5 is 5, 9 take away 8 is 1, 0 take away 0 is 0, and that's when my decimal point goes. So the number more than 5 is 0.15. These probabilities now add to 1. Question 12. The table shows some of the values of y equals 4x subtract 1 for the values of x from -1 to +1. So this inequality here just gives us our range of x values -1 through to 1, and then this is our equation, and what's happened is they've substituted these x values in to find these values, and for part A they want us to complete that table, so we're going to do the same. We're going to substitute those values in. Now this is a linear graph, so you can actually treat it like a sequence, okay? Or you can substitute. There's two ways to do it. So because it's a linear graph, all right, we can spot the difference between these two terms. So from 1 to 3 is 2, and work backwards by subtracting 2. So 1 subtract 2 is -1, subtract 2 again is -3, subtract 2 again is -5. So just be aware that you can do that, okay? So the difference between these two is 2, which means the difference between these two must be 2, and the difference between these two must be 2. And then the difference between those two. The other way that you can do this is you substitute in. So you find y when you substitute in an x value. So here, y equals 4 times something subtract 1. Well, if that's something 0, you put a 0 there. So y equals 4 times 0 subtract 1. Anything times 0 is 0. 0 subtract 1 is -1. So that's where the -1 comes from, okay? Doing it like sequences, so spotting the pattern, so going this way we add, working backwards we subtract, is easier than then having to substitute in -0.5 and 0.5. So it's just something to be aware of. 2 marks there, 1, 2. All right, part B. On the grid below, draw the graph of y equals 4x subtract 1 for the x values from -1 to 1. So these match up here. Okay, so we're working with this table. Now you actually only need 2 points to draw a straight line, but we have 5 points here that we need to make sure that that line goes through. So what I'm going to do is I'm going to plot this coordinate and this coordinate, okay? So this is x coordinate -1, y coordinate -5. So we're going to go across to -1, down to -5. Now remember, you would use a pencil for this. I'm using a pen so you can see it nice and clearly on this recording. Okay, and then I'm going to plot this coordinate. So the x coordinate is 1, the y coordinate is 3. So 1 and up to 3 there. Look, we're halfway between. Now if I draw a line between these two with a ruler, because it's a linear graph and I have to draw a straight line through, and if I make sure it covers the whole of the graph like that, we can double check, but I should have covered the other points. So when x is 0, y is -1, 0, -1, that works. When x is 0.5, y is 1. X is 0.5, y is 1. So just with those 2 points and our nice clear straight line, we've dealt with all of those coordinates there for those 2 marks. Question 13. Kit paddles a canoe out to sea from the point marked S. So he's starting here at point S. He stops when he is on a bearing of 160 degrees from S, and he's also 120 metres from S. Use the scale diagram below to find Kit's distance and bearing from T when he stops. So distance and bearing from T when he stops. We've been given a scale here. 1 centimetre represents 20 metres. Okay, so we need to draw these two. Or construct these two criteria on this diagram. So we are going to need a protractor and a ruler, and obviously you're going to do this in pencil on your exam paper, guys. I'm going to do it in pen, hopefully not make a mistake, so that you can see it nice and clearly. Okay, so the first thing I'm going to work with is this bearing of 160 degrees from S. From S means this is where I'm measuring my bearing from, okay? So what they've drawn for us, lovely, is a north line here. So that's where we're going to start measuring 160 degrees from, okay? We're going to take our protractor. We're going to take this middle point of our protractor. Yours might look different, but you'll have a middle point, or you might have a little circle that's a gap that you need to try and put that circle in. So that middle point is going to go on the dot where S is, and then this 0 line here is going to be aligned with my north line. So we're going to start by doing that. So as accurate as we can be. So my middle, where my protractor lines cross, is on my S dot, and my 0 line here that starts the measurements on the protractor is aligned with that north line. So we're going on a bearing of 160 degrees. Bearings need to be read clockwise, so that's why we're reading in this direction. And we're going to 160 degrees. Well, I'm going to read around the outside numbers here, because that's the direction I'm going in. So when I move round, 120, 30, 140, 150, 160. So I'm going to mark a really clear point there, because that direction is a bearing of 160 degrees from S. Okay? The next thing we're going to do is find out where 120 metres from S is. And we're going to have to work with this scale here, guys. Okay? So I'm going to go down to my working out at the bottom here, because we know that I like to use a proportion table, because it just organises my thinking a little bit. So this scale, 1 centimetre represents 20 metres. So we're dealing with centimetres and metres. 1 centimetre represents 20 metres. We want to figure out how many centimetres for 120 metres from S, okay? So we want our metres to be 120. Remember, when we're using a proportion table, we are scaling up or we're scaling down. 120 is bigger than 20, so we're scaling up, which means we've multiplied. Okay, well, how many times do we multiply 20 to get to 120? Well, 12 divided by 2 is 6. So 120 divided by 20 must also be 6. So we've times by 6 on this side. So we're going to do the same on the other side. So 1 times 6 tells me that 120 metres is 6 centimetres. So I'm going to go back to here, and I'm going to use my ruler this time, guys, okay? So I'm going to put my 0 of my ruler on S, and I'm going to align my ruler with the dot that I placed for my 160 degree bearing. So we want it to be on that bearing and this distance, okay? So I'm using my pen on the dot there, because then I can align my 0 with my pen and then keep it there while I'm moving to align with this dot that I placed for the 160 degrees. Now we worked it out to be 6 centimetres, so from 0, 1, 2, 3, 4, 5, 6. So this is where T is when he stops. Now you can draw a faint line if you want to. Nobody's going to judge you for that. So this is where Kit is when he stops. Sorry, I just said T and I didn't mean that. So that's where he is when he stops. 160-degree bearings, and that's 6 centimetres, about 120 metres. So this is where he stops paddling, okay? Now we need to use this point here, and we want to find his distance and bearing from T. So we want to know how far he is from T and on what angle he is from T, okay? So what I'm going to do to start off with to make my life easier is I'm going to join T and where Kit stops up. Okay, made it nice and clear that's where he stops, because they're going to check your constructions, they're going to check your bearing and your measurements, guys. You get a little bit of leeway either way, but be as accurate as possible. So the first thing I'm going to do is I'm going to find my distance, okay, because that just requires me to measure this line and then do some converting. All right, so let's draw myself another proportion table just to figure out the distance from T. So this is where we're working from T here, so I'm going to put that there, and that's where we were working towards stopping, just so we don't get confused with our working out. So centimetres and metres, 1 centimetre from our scale is 20 metres. So let's measure up how many centimetres from T he stops. So again, I'm going to put my pen there, put my 0 on, and then I'm going to do that, and then to here, 7.5 centimetres, 7.5 centimetres, okay? So remember, we scale up or we scale down with a proportion table. So 7.5 is bigger than 1, so we've multiplied. And 1 times 7.5 gives me 7.5. So now I need to do the same to the other side. So 20 times 7.5, okay? I'm going to use some space down here because I have space. So 20 times 7 and 20 times 0.5. 7 and then 0.5. 20 times 7, well, 2 times 7 is 14. So 20 times 7, 20 is 10 times bigger. So that must be 140. 20 times 0.5 is the same as halving 20. Okay, so half of 20 is 10. So we're going to add those together. So that gives us 150 metres. So he's 150 metres from T. We now need to find that bearing. So we need to measure a bearing from T. So we're measuring this angle from the north line all the way around to that line we drew there. Now what we need to recognise is my protractor is only half a circle. It's a semicircle. So it's only going to go to 180 degrees. And then I've got a little bit extra I need. So I'm going to make my life easy here, guys. Okay, I'm going to put my ruler aligned with the north line. And then I'm going to draw myself a line down here. Because that is 180 degrees. I know that because that's my half of a circle. So I'm interested in this extra little bit here, then I can add it to 180. So what I'm going to do now is turn my page, and I'm going to put my protractor, like I did before, the middle part on T. I'm going to align my 0 line with the line I've just drawn because it's aligned with the north line. So let's do that. In the middle, align it with the line you just drawn, and then we are measuring around to this line here. So from here to here is 20 degrees. So if I turn that round, it's 20 degrees. I want the total bearing, so I want all the way round. So I want 180 plus 20 for this bearing. So 180 plus 20 is 200. So my bearing from T is 200 degrees. Be wary with bearings, you have to give them as 3 figures. So if that was less than 100, I would have to put a 0 in front to make sure it's 3 figures. But we're okay here with these two. Question 14a. Calculate 9 over 14 and subtract 2 over 7. So we're subtracting fractions here. When we're subtracting fractions, we need a common denominator. Adding or subtracting, we need a common denominator. So I need the bottom numbers to be the same. So I'm going to have to scale up or down a fraction to make those denominators the same. Now, this question, I know that 14 and 7 are both in the 7 times tables. So I only need to change one of these fractions, guys. I'm going to scale 2 over 7 up to be a fraction over 14. So my 9 over 14 is going to stay as it is, but I'm going to scale up my 2 over 7. So to scale it up, 7 times 2 is 14. So I'm multiplying my fraction by, excuse me, by 2. I have to multiply the top and the bottom, okay? So 2 times 2 gives me a numerator of 4. 7 times 2 gives me that denominator of 14 so that they match. And I've still got that subtraction sign in between there. Now that the denominators are the same, I can just work with the numerators, okay? The denominator is going to be 14 because they match, but the numerator would be 9 subtract 4. So I'm subtracting the numerators now that I have a common denominator. 9 subtract 4 is 5, so our answer is 5 over 14. Part B, calculate 10/13 multiplied by 1/5. Give your answer in its simplest form. When we're multiplying fractions, we don't need to change anything. We just multiply the numerators together and the denominators together. So 10 times 1 will be on the top of our new fraction, and 13 times 5 will be on the bottom of our new fraction. 10 times 1 is 10, so we have a numerator of 10. Now we need to do 13 times 5. So 10 times 5 and 3 times 5. That's 50 and 15, so that's 65. So we get a new denominator of 65. Now it wants our answer in its simplest form. So we're going to look and see what numbers we can divide the top and the bottom by. We have to divide them both by the same number. So one ends in a 0, one ends in a 5. So I can definitely divide them both by 5 because numbers in the 5 times tables end in 0 or 5. So 10 divided by 5 gives me a numerator of 2. And then I'm doing 65 divided by 5. Okay, you can do that however you want to do. If you don't know what it is, 5s into 6 is 1, remainder 1. 5s into 15 is 3. Well, actually, yeah, 5s into 15 is 3, so our answer is 13. Question 15. Sarah borrows £4,200 from her friend at a rate of 2% simple interest per year. She agrees to pay back the £4,200 plus the interest in one payment at the end of 5 years. How much should Sarah give her friend at the end of the 5 years? So we need to figure out how much interest per year on 4,200 and then find out 5 years worth and then add that to the amount that she's borrowed. So simple interest, the way this works is you find 2% of that amount and then you times it by the number of years. It is that simple. It's called simple interest. So we're going to find 2% of 4,200, okay? So I'm going to find 1% and then 1%, because 1% plus 1% is 2%. So to find 1%, we have to divide by 100, because 100, what a percentage is out of, divided by 100 will give us 1. So 4,200 divided by 100 is 42. We want another 1%, so we want another £42, and we're going to add those together. So 2 plus 2 is 4, 4 plus 4 is 8. So that's £84 is 2% interest, and we get that per year. So that's for 1 year. We're working with 5 years here, guys. So we're going to do 84 times that 5 years. And I'm going to split it. I'm going to do 80 times 5 and 4 times 5. Well, 8 times 5 is 40. So 80 is 10 times bigger. So that must be 400. 4 times 5 is 20. We're going to add those together. So 0, 2, 4. So this is the total interest, guys. Total interest. So after the 4 years, Sarah's going to pay back the 4,200 she borrowed plus this interest in one payment. So let's add those together. 4,200 plus the interest of 420. So that's 0, 2, 6, 4. So she's paying back £4,620 at the end of the 5 years. Question 16. Calculate the size of an interior angle of a regular 10-sided shape. They've given us the name of that 10-sided shape there, guys. It's a decagon. We want to know the size of an interior angle. So just one interior angle. And if it's a 10-sided shape, there's 10 angles inside that shape, okay? But we're only interested in the size of one of them, so we're not dealing with the sum of the angles. Okay, so there's a relationship between the interior angle and the exterior angle. So the interior angle plus the exterior angle is equal to 180. So if I find the exterior angle, I can take it away from 180 to find this interior angle. So there's a formula we need to know, guys. So to find the exterior angle of any polygon, okay, you do 360 divided by n. So n is the number of sides. So 360 divided by 10 will tell us the exterior angle, okay? So 360 divided by 10 is 36. So that's the exterior angle. So the exterior angle of this polygon is 36 degrees. Well, we know that the interior plus the exterior is 180 degrees. So we're going to take that 36 away from 180. So 180 take away 36. 0 take away 36 I can't do and get a positive answer. So I'm going to borrow from here. That's 10. 10 take away 6 is 4. 7 take away 3 is 4. 1 take away 0 is 1. So the size of the interior angle is 144 degrees. Question 17. One summer, Sean grew runner beans. Each week he recorded in kilograms the total mass of the runner beans he picked. The results for the first 4 weeks are given below, so 3.6, 3.4, 2.9 and 5.1. For the first 5 weeks, the mean mass of the runner beans Sean picked was 4.2 kilograms per week. How many kilograms of runner beans did Sean pick in week 5? We've got to show all our working out. Okay, so when we work out the mean of a set of numbers or set of data, we add all of them together and divide by how many pieces of data we had. So that's what's happened here to get 4.2. We've added the first 5 weeks together, then divided by 5 to get 4.2. Now, they've only given us the value of the first 4 weeks, so the first thing we need to do is find out what the total of the first 5 weeks are. So we're going to reverse that process. Instead of dividing by 5, we're going to start by multiplying that mean by 5. So we're going to do 4.2 kilograms multiplied by 5. Okay, so we're working with decimals and a whole number. So I'm going to multiply 4.2 by 10. So I'm going to do 42 times 5. Okay, which is 40 times 5 and 2 times 5. 40 times 5, well, 4 times 5 is 20. 40 is 10 times bigger, so that must be 200. 2 times 5 is 10, so that's 210. Okay, so that equals 210, but we times by 10, so we've got to reverse that process. We've got to divide by 10, so 4.2 times 5 must be 21. So the total is 21 kilograms. Now we know what 4 of the weeks were. We're trying to find week 5. So if we add these 4 together and take them away from 21, then we will know what the how many kilograms he picked in or grew in week 5. So let's add these together. So we're going to do 3.6 plus 3.4. I'm just going to deal with 2 at a time so that I don't have a big long column that I get confused with. So 6 plus 4 is 10, carry the 1. Decimal point needs to match. 1 plus 3 is 4, plus 3 is 7. So I'm at 7 at the minute. So I'm going to do 7 plus 2.9, making sure my decimal point and my place value lines up. 0 plus 9 is 9. 7 plus 2 is 9. My decimal point in the same place. Now I'm doing 9.9 plus 5.1. So 9.9 plus 5.1. 9 plus 1 is 10. Decimal point in the same place. 1 plus 9 is 10, plus 5 is 15. So 15 kilograms in total here, okay? 21 kilograms for the 5 weeks. So we're going to do 21 take away 15. Well, 1 take away 5 I can't do and get a positive answer, so I'm going to have to borrow. 11 take away 5 is 6. 1 take away 1 is 0. So that 5th week must be those 6 kilograms, because that's the difference between the first 4 weeks and the total for the 5 weeks. So we're going to pop 6 kilograms there. So we've reversed the mean. Question 18. So the diagram shows triangle A. So this is triangle A. Part A, reflect triangle A in the line y equals 4 and label your answer B. So we're reflecting this triangle in the line y equals 4. So the first thing we need to do, guys, is draw that line y equals 4. Again, I'm going to use a pen, but you're going to use a pencil in your exam. So if you make a mistake, you can cross it out. So y equals 4 is 4, a line going through 4 on the y-axis. So this is the y-axis. That's where 4 is. So I'm going to start by drawing my line through the point 4 on the y-axis. Okay, it's a horizontal line going through y at 4. And it's y equals 4 because every point on that line will have a y coordinate of 4. Okay, so I've drawn the line and now I need to reflect triangle A over it. So I need to reflect the shape over it. I'm going to take it a corner at a time. This point here is already on the line, so that's not going to move. That's what we call an invariant point. So that point is going to stay exactly where it is because it's on the line, so it doesn't need to move. This point is 1, 2, 3 squares from the line. So we're going to go 3 squares from the line in the other direction because we're flipping it over. So 1, 2, 3 there. This point or vertex or corner is 1 away from the line. So we're going to put it 1 away from the line on the other side. And then we're going to, with a ruler, nice and clearly draw our shape. Again, guys, you will use a pencil in case you make a mistake and you need to rub something out. Label your answer B. So let's put B in there. Okay, so that's our first 2 marks. Next, part B, translate triangle A using the vector 6, 0, label your answer C. So again, we're done with B now. B doesn't exist to us at this point. We're working with triangle A again and we're translating it. So translating it just means to move it. Okay, we're moving according to this vector. So on the top of the vector, we go left or right. So we're moving in the X direction. On the bottom of the vector, we go up or down. So we're moving in the Y direction. The Y direction is 0. So they're not moving up or down anyway. We're just moving left or right. This is positive. Positive, we move right. Negative, we move left. So everything's moving 6 places to the right. Okay. So we're going to take it a corner at a time again. So this corner, I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. Notice I'm using exact corners here, guys, and you'll notice it's gone from -1 to +5. That's 6 places. Okay, this corner, 6 places. 1, 2, 3, 4, 5, 6, and then this corner, 6 places again. 1, 2, 3, 4, 5, 6, and then we're going to draw with a ruler nice and clearly our shape. Again, you will have used pencil. Then if you do make a mistake, you can rub it out so it's not confusing for the examiner. And then it told us to label this C. So we're going to label it C. Question 19. Bryn lives in Canada. When he bought a book from the UK for £240, the exchange rate was £1 is 2.5 Canadian dollars. When he sold the same book to a person in Japan for 162,000 Japanese yen, the exchange rate was 1 Canadian dollar equals 81 Japanese yen. Show that Bryn made more than 1,000 Canadian dollars buying and selling this book. Okay, so there's a lot of words there, guys, and we've got 2 different exchange rates. But what's important here is we're trying to show that he made more than 1,000 Canadian dollars buying and selling this book. So we want both of these values to be in Canadian dollars. Okay, so we're going to start by converting what he spent. Okay, so he spent, and we're dealing with pounds and Canadian dollars. So I'm going to do myself a little proportion table. We know I like those, done those loads in this exam paper. Okay, so we're doing pounds to Canadian dollars. And £1 is 2.5 Canadian dollars. Okay, so we're converting our £240. So that's going to go in our pounds column. So £240 into Canadian dollars. So we want to compare both of these values in Canadian dollars to show that this is true. Okay, remember with a proportion table, we're scaling up or we're scaling down, so we are multiplying or we are dividing. To get from 1 to 240, we've got bigger, so we've multiplied, and we must have multiplied by 240. So I need to do the same to the other side. So I'm doing 240 times 2.5 to find out how many Canadian dollars he spent, okay? So 240 times 2.5. Well, 240 times 2. Well, 24 times 2 is 48. This is 10 times bigger, so it must be 480. And then we want that 0.5. We want half of that. Well, half of 240, we divide by 2. So that's 120. So that's 0, 0, 600, okay? So he spent 600 Canadian dollars on that book, okay? Now we're going to find out how many Canadian dollars he sold it for. So we're working with what he sold it for here, okay? So we're using a new proportion table because we're working with a new exchange rate. So we're doing Canadian dollars. So let's put Canadian dollars to Japanese yen. So 1 Canadian dollar is 81 Japanese yen, okay? We've got 162,000 Japanese yen. So we're going to scale down this time. We need to figure out what we're dividing by. Okay, so we're going to do 162,000 divided by 81. So that's going to be the tricky thing for us to do here. 162,000 divided by 81. Okay, so we're going to do 162,000 divided by 81. Now, 81 is a small number. So what I'm going to do is I am going to, well, a couple of options here. I'm going to write it as a fraction, okay, to start off with, because I like to work with fractions. You might not, but I do. And then I'm going to use the rules of divisibility, okay. I'm going to start with the number 2. Can I divide 162,000 by 2? Yes. Can I divide 81 by 2? No, it's not an even number. Okay, let's start by 3. Can I divide them both by 3? The rule of divisibility for 3 is if you add the digits together and you get a number in the 3 times tables, you can divide it by 3. So 1 plus 6 plus 2. So 1 plus 6 is 7, plus 2 is 9, and then they're all zeros. This adds to 9, so I can divide 162,000 by 3. Let's check 81. 8 plus 1 is 9. 9 is in the 3 times tables. So I'm going to start by dividing them both by 3, guys. Okay, and I am going to use this blank space down here. So I'm going to do 162,000 divided by 3. So 3, 6, 9, 12, 15, 18. 3 is into 16. 1, 2, 3, 4, 5. Remainder 1. 3 is into 12. 1, 2, 3, 4. No remainder, so I need to carry those zeros up, guys, okay? Now I'm going to do 81 divided by 3. 3 is into 8. 1, 2. Remainder to get from 6 to 8 is 2. 3 is into 21. 1, 2, 3, 4, 5, 6, 7. No remainder, so that gets us 27. Now, these numbers I can deal with a little bit easier, guys, because 54 and 27, 27 is half of 54, okay? So I can divide both of these by 27. So when I divide my bottom number by 27, it's 1. When I divide the 54 by 27, it's 2, but I've got those 3 zeros there, sorry. And then 2,000 divided by 1 is 2,000. So it's 2,000 Canadian dollars that he sold it for. Remember, we were working out Canadian dollars. Okay. We want to show that he made more than 1,000 Canadian dollars buying and selling this book, so we want to see the difference. So we're going to do 2,000 divided by 600. We're comparing the Canadian dollars, guys, which is 1,400. 1,400 is more than 1,000, so we've shown he made more than 1,000 Canadian dollars by buying and selling that book. Question 20A. Tick the 2 correct statements about this. Okay, so these are the statements we've got to choose from. It's an equation, it's true for all values of x and y, it's an identity, it's only true for certain values of x and y, it's an inequality, it is true for only one value of x and only one value of y. So what we need to look at here is this symbol in the middle. So that's not an equal sign, that's 3 lines. That is the identity symbol, okay? So we've got this here, it's an identity, so I'm going to tick that straight away. And the key thing, if you've got the 3 lines there, the identity symbol, it means that the left-hand side is exactly the same as the right-hand side, and it is true for all values of x and y, regardless of what x and y are. It's true because it's an identity, so I'm going to mark that statement as well. The rest of them are not appropriate for this question. Part B, in this part of the question, all lengths are in centimetres, so that's what we need to recognise that there. So we've got a diagram of a prism here. It's not drawn to scale, so we can't measure anything directly from it. The diagram shows a prism. The cross section of the prism is a triangle with height x and base 3x. So this triangle here is the cross section of the prism. So that's the uniform shape that goes all the way through. So no matter where we would chop this shape down, we're always going to have that triangle shape, a bit like a Toblerone. Okay, the volume of the prism is 216 centimetres cubed. Use an algebraic method to find the height of the triangle. So we're trying to find out what x is, the height of that triangle. They've given us enough information. We just need to form and solve some kind of equation here. Okay, so they tell us what the volume is. So to work out the volume, we would find the area of the cross section. So we would do area of the cross section multiplied by the depth or the other length that they give us. So we would find the area of this triangle and then we would multiply it by 4 because it's that length there that makes this shape then become 3D. So let's find the area of the cross section. It's a triangle. So for a triangle, we do the base times the height and then we half it. So the area of the cross section is 3x times the height, which is x, halved, and then we would multiply it by 4. Okay, x times 3x. So the volume is x times 3x is 3x squared, still over 2 multiplied by 4. I'm going to simplify this a little bit more. So this is 4 over 1. So 3x squared times 4 is 12x squared. 2 times 1 is 2. And then 12x squared divided by 2 leaves me with 6x squared. So the volume is 6x squared, but we know that that's equal to 216 centimetres. So 6x squared equals 216 centimetres. So I'm going to divide by 6. So 216 divided by 6. 6, 12, 18, 24. 6 is into 21. 1, 2, 3. Remainder 3. 6 into 36. That's 30. 36. 1, 2, 3, 4, 5, 6. 36. So that's 36. Now we need to find out what x is. X equals, well, the inverse of squaring would be to square root. So x equals the square root of 36, which is 6. So the height of the triangle is 6 centimetres. Question 21a. Mary and Paul run 100 metres. Mary's time is between 14 and 15 seconds inclusive. Paul's time is between 12 and 13 seconds inclusive. Complete the inequality to show the least and greatest possible difference between the times of these two runners. So let's compare these times then, okay? So if Mary runs 14 seconds, but Paul runs 12, then the difference is 2. If Mary runs 14 seconds, but Paul runs 13 seconds, then the difference is 1. We're now going to compare if Mary does 15 seconds. So if Mary does 15 seconds, but Paul does 12, the difference is 3. If Mary does 15 seconds, but Paul does 13, then the difference is 2. Okay, so we want the least and the greatest possible distance. So the smallest difference is 1. The highest difference is 3. Part B. Peter wants to go by ferry to France. He's taken a van and a small trailer. He knows the van is 590 centimetres long, correct to the nearest 10 centimetres. The trailer is 200 centimetres long, correct to the nearest 10 centimetres. The ferry company uses the following rules for the length of vehicles. So a small trailer can have a maximum length of 2 metres and a van can have a maximum length of 6 metres. So first thing to note, this is metres, this is centimetres. Okay, we want them to be the same to be able to compare them. So let's do that. 2 metres times by 100 would be 200 centimetres. 6 metres times by 100 would be 600 centimetres. So we've got centimetres and centimetres, which makes me happy. Peter thinks that the length of his van and the length of his trailer will both fit the rules. Use lengths to give one example to show how he may be correct and one example how he may not be correct. So we want a may be correct option and a may not be correct option. So what we're working with here, because it's correct to the nearest 10 centimetres, are upper and lower bounds, okay? So we're going to want the upper bound for the van and the lower bound for the van. And we're going to want the upper bound for the trailer and the lower bound for the trailer. So the highest possible length it could be and the lowest possible length it could be. And then we can look at all different options. So upper bound for the van. Well, if it's rounded to the nearest 10 centimetres, we half this and that's what we take off or add on to get our upper and lower bounds. So 10 divided by 2 is 5 centimetres. So for our upper bound, 590 plus 5 is 595 centimetres. For our lower bound, 590 subtract 5 is 585. Okay, we're going to do the same with our trailer now. 200 centimetres to the nearest 10 centimetres. So we're adding on and taking off 5 for our bounds again. So our upper bound will be 200 plus 5. Ooh. And our lower bound would be 200 subtract 5. Okay, so everything's in centimetres here. So we're looking for a combination of these things that may be correct and may not be correct. Okay, so the maximum length of the van and the trailer together, so 600 plus 200 is 800 centimetres. So we're looking for a combination of upper bounds and lower bounds that might be correct, so that gets us less than 800, or may not be correct, it gets us more than 800. Okay, so the may not be correct is more than likely going to be if the van and the trailer are at their maximum length. Okay, so maximum length. So let's highlight this, may not be correct if we're dealing with the upper bound of our van and the upper bound of our trailer. Okay, so let's try that. Upper bound of our van, so maximum length of the van is 595 plus the max length of the trailer, which is 205. Well, 595 plus 205 equals 7. 800, so this may not be correct because we're pushing it very much to the limit of the maximum, okay? But it may be correct, let me get a different colour. It may be correct if we use our lower values, okay? So if we have our lower length of our van and our lower length of our trailer, it may fit within that 800. So minimum length of the van is 585, and then we're going to add the minimum length of the trailer, which is 195. So 585 plus 195. 5 plus 5 is 0. 9, 18, 780. So that could work because it's less than 800. So we've given two options. It could be correct if the length of the van and the trailer are the lowest they could be, but it may not be correct if the length of the van and the trailer are the maximum they could be, because it will push it right to the limit of the maximum length on the ferry. Question 22a. Work out 6 times 10 to the power of 5 divided by 20. Give your answer in standard form. Okay, the first thing we're going to do is we're going to convert 6 times 10 to the power of 5 into an ordinary number. So 6 times 10 to the power of 5. 10 to the power of 5 would be 100,000. So we're doing 6 times 100,000. So that's 600,000. So we're doing 600,000 divided by 20. So 600,000 divided by 20. So I'm going to divide top and bottom by 10. So then I'm doing 60,000 divided by 2, which is 30,000. So I'm just halving it. I want my answer in standard form. So standard form needs to be a number between 1 of 10 multiplied by 10 to a power. Okay, so I am going to multiply by 10 to a power. My number between 1 and 10 is going to be 3. And to get from 3 to 30,000, I need to multiply 3 by 10,000. So 10,000, 1, 2, 3, 4. So that would be 10 to the power of 4. So that's my answer in standard form. Part B. At midday, the volume of water flowing over a waterfall, so this is at midday, is 3 times 10 to the power of 8 litres per minute. At midday, what is the volume of water flowing over the waterfall in litres per hour? Give your answer in standard form. Okay, so we're given 3 times 10 to the power of 8 as litres per minute, but we're working in litres per hour. So we're going to want to multiply by 60. There are 60 minutes in an hour, okay? So you want to multiply that by 60. Well, 60 times 3 is 180. 180 times 10 to the power of 8. Now we want our answer in standard form. Standard form is a number between 1 and 10 multiplied by 10 to a power. 180 is not a number between 1 and 10. So we are going to have to divide 180 by 100. Which would give us 1.8, which is between 1 and 10. But because we've divided by 100, that means we'd need to multiply by another 100 on the end here. So we'd have 10 to the power of 8 times by 100 to get it back to its original value. But we want it to be 1.8 times 10 to a power. Well, 100 is 10 squared. And then if we use our laws of indices, 10 to the power of 8 times 10 to the power of 2, we add our powers. So it becomes 10 to the power of 10. Question 23a. Find the next term of the following Fibonacci type sequence. So the way a Fibonacci sequence is, you add the previous 2 terms to find the next term. So 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34. So now we're doing 21 plus 34. So the next term is 55. Part B. Find the nth term of the following sequence. Okay, so we need to see what the sequence is going up or down in. Now the sequence is going up. It's an increasing sequence. To get from 4 to 9, we add 5. 9 to 14, we add 5. 14 to 19, we add 5, and 19 to 24, we add 5. It's important you check that it's increasing or decreasing by the same amount for it to be a linear sequence. Otherwise, we do something entirely different. So it's going up by 5 every time. So we can start our nth term rule by 5n. Now we need to compare this 5 to the first number in the sequence. What do we need to do to 5 to get to 4? Well, we need to subtract 1. So we're going to write subtract 1 on the end there. So our nth term rule is 5n subtract 1. Question 24. A glass of water is placed on a small table and the table stands on horizontal ground. Part A. The total mass of the table and the glass of water is 9.6 kilograms. We're given the ratios. The mass of the table to the mass of the glass of water is 11 to 1. And the mass of the empty glass to the mass of the water is 3.5. What is the mass of the empty glass? Okay, so we're working with 2 different ratios here. So the thing to note first is that the mass of the table and the glass of water has a total of 9.6, which relates to this ratio here, mass of table and mass of water. So we're going to go table to water, and it's 11 to 1. The total is 9.6. Well, 11 plus 1 is 12. So we're doing 9.6 divided by 12. Okay, I'm going to start by writing that as a fraction, but then I'm going to multiply top and bottom by 10 because I don't want that decimal number there. And then what I'm going to do is I'm going to simplify this fraction as far as I can. Now 9 plus 6 is 15, that's in the 3 times tables. 1 plus 2 is 3, that's in the 3 times tables. So 96, we're going to start by dividing by 3, is 32. 120 divided by 3 is 40. These are both even numbers, so we're going to divide by 2. So that's 16 over 20. Okay, I want to know what this is as decimal, so I'm going to make it over 100, guys. So I'm going to times by 5. 20 times 5 is 100. 16 times 5 is 80. So that's 0.8. So each part of this ratio is worth 0.8. So 1 times 0.8 is 0.8. And 11 times 0.8 must be the 9.6, take away the 0.8, which is 8.8. Okay, so we now have the mass of the glass of water. So that's when it's full. Okay, so now we're going to use this mass of the glass of water with the mass of the empty glass and the mass of water. So we're moving to our new ratio, guys. So we're doing the empty glass to the water. Okay, and they are in the ratio 3 to 5. Well, we know that the mass of the glass of water is 0.8, but we don't know what the mass of the empty glass and the mass of water are separately. But if that's 0.8, then that's the total for this ratio. So let's add this ratio together. 3 plus 5 equals 8. So that total for the glass of water is 0.8 divided by 8, which is 0.1. So we want the mass of the empty glass, so we're going to times that by 0.1. 3 times 0.1 is 0.3. So the mass of the empty glass, which is what we're looking for, is 0.3. And we've been working in kilograms, so let's leave it like that. 0.3 kilograms. Okay, part B. 1 second. So we're using the formula for pressure, so force divided by area. The base of the table has an area of 1,600 centimetres squared. Some books are also placed on the table. The books, the glass of water and the table exert a pressure of 0.1 newtons per centimetre on the ground. So that's the books, the water and the table. Calculate the force exerted on the ground by the books, glass of water and table. Assume that the whole of the base of the table is in contact with the ground. Okay, so pressure equals force divided by area. So we're given the area as 1,600. We're trying to work out the force and we're given the pressure of 0.1. Okay, so the force is equal to 1,600 times by 0.1. Okay, so what we're going to do, let's times that by 10. So we're doing 1,600 times by 1, which is 1,600, but we times by 10, so we'll need to reverse that. We're going to divide by 10, so it's 160 newtons, but you can just put 160 there, guys, you would be absolutely fine. Part C, in fact, the assumption made in part B is incorrect. Okay, so this assumption here, part of the base of the table is not in contact with the ground. Describe how this changes your answer to part B. Okay, so if the whole of the base of the table is in contact with the ground, we're dealing with this whole area. Okay, but if the whole of the base of the table isn't in contact with the ground, the area is going to be less. So if the area is going to be less, then the force would be less too. So you can just write that. The force would be less. Question 25. So we've got sale 40% off, a ring, and its reduced price is £1,008. So in a sale, jewellery is reduced in price by 40%. The price of the ring is reduced to £1,008 in the sale. What was the price of the ring before the sale? So we're trying to find the original value. So with 40% off, it costs £1,800, okay? So the original price would be 100%. So I'm going to use a proportion table here with some other working out, just to organise my thoughts, okay? So we're going to deal with the price and the percentage. So the reduced price is £1,008 with 40% off. So that 40% is the original 100%, take away 40%. So we're working with 60%. So 60% is £1,008, okay? So I'm going to divide by, divide by 6, yeah. I'm going to make 10%. So let's divide by 6. So I'm scaling down to 10%. So I'm going to divide this by 6. So 1008 divided by 6. So 6, 12, 18, 24, 30, 36, 42. So 6's into 10 is 1, remainder 4. 6's into 40, 1, 2, 3, 4, 5, 6. Remainder 4. 6's into 48. I haven't gone far enough. 42, 48. 1, 2, 3, 4, 5, 6, 7, 8. No remainder, so that is £168. So that's 10%. We want the original price, so we want 100%. So now we're scaling up. To get from 10% to 100%, we're going to times by 10. Do the same on the other side. So that will be £1,680. So that is our price of the ring originally before the reduction in the sale. Question 26. Expand and simplify, and then we've got double brackets here. So it's up to you how you do this. I'm going to use a grid, guys, because it helps me organise my thoughts a little bit, and then I don't miss anything out. So this bracket here, I'm going to put 3x and minus 4. 3x minus 4. This bracket here, it's 5x and plus 7. Notice that the signs are going with them, and we're treating this as a multiplication grid. So in this square here, we're going to do 3x times 5x. Well, 3 times 5 is 15, and x times x would give me x squared. In this box here, we're doing 3x times positive 7. Well, it's a positive times a positive. So we're going to get a positive. 3 times 7 is 21. So that's 21x. This box here, negative 4 times 5x. A positive times a negative times a positive gives me a negative. 4 times 5 is 20. So that's 20x. And then in this box, negative 4 times positive 7. Negative times a positive gives me a negative. 4 times 7 is 28. So now we're going to simplify this. We've got 15x squared. We combine the diagonals. So we've got negative 20x plus 21x. So that's plus 1x and then minus 28 on the end. Part B, factorise each of the following. So we're going to do this first one. So when we factorise, we're pulling out the highest common factor of each term, and then we're putting that on the outside of the bracket. So I'm going to split these terms down. 2x squared y is 2 times x times x times y. Okay. 12x squared y is x times y, but I'm going to split that 12 into 2 times, and it's 2 times 6, because I want to pull out common factors, so it made sense for me to split 12 into 2 times 6, so we've got a matching factor of 2. So we're going to factorise, so it means we're putting in one bracket here, okay, one bracket, and we're going to pull out what they have the same, so we can take a 2, an x and a y. That's why I lined them up the way that I did as well. So we can have 2xy on the outside, so that's those dealt with. And then on the inside, in place of these terms goes what's left. So instead of 2x squared y, we're going to have x, and it's a plus. And then instead of 12x squared y, we're going to have 6 times y, which is 6y. Part 2. So we are factorising x squared minus 64. This is the difference of 2 squares. So we're going to have 2 brackets for this, guys. 2 brackets. The reason why we have 2 brackets is we have a squared term. To get that square, x squared, we need x times x. But we also have a constant number term. To get that constant number term, we need 2 numbers to multiply together. Now, difference of 2 squares. The squares is our hint. So 64 is a square number. Square root of 64 is 8. So we need -8 and +8, so that when we expand that bracket, the x term that would be in the middle, like we got up here, disappears and we're just left with x squared and 64.